Hi everyone, this is Samvat Sankanavar. I welcome you all back to my channel Mathshala. We are looking into the solution to RD Sharma Exercise problems, and this video is going to be the continued part of exercise 9.6 of arithmetic progression chapter. If you are not aware, let me inform you that you can also download the PPT in the form of PDF by clicking on the link provided in this video description for your future reference as notes. First question of this video is going to be question number 21, which says find the sum of first 51 terms of an AP whose second and third terms are 14 and 18 respectively. Let us see how we can proceed with this problem. First, let us note on the given data. Second term is given to us, that is A2 is equal to 14, and third term is given, that is A3 is equal to 18. And he has asked us to calculate sum of first 51 terms, that is S51. Now, using this formula, we can get common difference of this AP, substituting all the values. I have explained in my previous videos, if any two terms of an AP are given, using those two terms, how we can get the common difference D. So this is the formula you making use of this formula, we can get the common difference D here. Here an is nothing but 18, which is the bigger term of these two, and ak is the smaller term, that is 40, and n is a subscript of that bigger term, and k is subscript of that smaller term. Therefore, 18 minus 14 is equal to 3 minus 2 into d. When I take this bracket on the left hand side, it will be d is equal to 18 minus 14 is 4, and 3 minus 2 is 1. Therefore, common difference of this AP is going to be equal to 4. Now, using this information, further I can get first term of an AP. That is, I can represent third term of an AP as A plus 2D. We all know that any term can be represented as an equal to A plus n minus 1 into D. Therefore, in place of n, if it is 3, A plus 3 minus 1, that will be 2D. Therefore, A3 can be represented as A plus 2D. Now, substituting the value of D in this, I'll get a term because I already know what is the third term. Therefore, in place of A3, I'll substitute 18, which is given to me. And in place of A, I'll keep it as it is. In place of D, I'll substitute 4. When I simplify this, I get value of A as 10 here. Now, I have value of A, I have value of D, and I also know up to how many terms I need to calculate the sum. Therefore, using formula of calculating sum of n terms of an AP, that is Sn equal to n by 2 into 2a plus n minus 1 into d, and substituting all the available values in this equation, I will get S51 is equal to 51 by 2. 2 into, in place of A, I'll substitute 10, and n minus 1, in place of n, I'll again put 51, and in place of D, I'll put 4 here. Simplifying this, I'll get 51 by 2, I'll keep as it is, and 10 into 2 is 20. 51 minus 1 is 50 into 4 is 200. Simplifying this, 200 plus 20 is 220, and 220 by 2 is 110. 110 into 51, I'll get answer as 5610. Therefore, sum of 51 terms of this AP is going to be equal to 5610. Coming to the next question, question number 22, which says if the sum of 7 terms of an AP is 49 and that of 17 terms is 289, find the sum of n terms. Here, instead of giving two terms of an AP, has given sum up to 7th term and sum up to 17th term, and he has asked us to find Sn formula generalized in terms of n, which means if I substitute value of n, I should directly get the sum of those many terms. Let us see how we can solve this. First, we'll note on the given data. Sum of 7 terms S7 is 49 and sum of 17 terms is 289. We know the formula of sum of n terms of an AP, that is Sn equal to n by 2 into 2a plus n minus 1 into d. This is generalized formula for any AP. Now we need to, using this given information, we need to simplify this formula in such a way that after substituting n value in this equation, we should directly get the answer of that many terms of this AP, sum of those many terms of this AP. In order to do that, using these two available information, first we need to calculate A and then we need to calculate d. Then if I substitute them and simplify everything, only n terms will be remaining on the right hand side. So let us do that. Using first information, that is S7 equal to 49, I'll substitute in this equation. Therefore, 49 is equal to that 49 sum is up to n 7 terms. Therefore, 7 by 2 into 2a, because I don't know a, and also d is unknown, and n is 7 minus 1 again. Now simplifying this, I get an equation here, that is 7 equal to a plus 3d. This is equation number 1. Similarly, I will solve for this term also. When I do it, I'll get one more equation, that is equation number 2. Now, if you see these two equations, they look like pair of linear equations because we have two linear variables present in this equation and also in this equation, and those variables are both are same. Therefore, using these two pair of linear equations, I can find solution, that is nothing but I can find a and d. Now what I'll do is I'll subtract 1 from 2. When I do that, 17 minus 7, like all the terms that are present on the left hand side are subtracted and all the terms present on the right hand side are subtracted. When I do that, 17 minus 7 is equal to a plus 8d minus a plus 3d, that I have represented here. When I do this, 17 minus 7 is 10, a plus 8d, and when I open this bracket, minus a minus 3d. So plus a and minus a get cancelled. 8d minus 3d is nothing but 5d. Therefore, I get value of d is equal to 2 here. Then I'll substitute this in equation number 1. Value of d in equation number 1. When I do that, 7 equal to a plus 3 into 2. Therefore, when I solve this for a, I'll get a value as 1 here. Now, using this information of a and d, I can simplify this formula, that is Sn formula, so that we can have a generalized formula to calculate sum of n terms particular to this AP. Therefore, using the formula Sn equal to n by 2, 2 into a. In place of a, I'll put this value, that is 1. N minus 1 into d. In place of d, I'll substitute 2 here. When I simplify this, n by 2 as it is, 2 into 1 is 2, plus when I multiply this 2 inside this bracket, that will be 2n minus 2. So here again plus 2 minus 2 get cancelled, and I'll be having n by 2 as it is, and inside the bracket only 2n will be remaining. Further, we can cancel this and this 2 and this 2 here, and only n into n will be remaining. Therefore, Sn equal to n square. Therefore, in this case, sum of n terms of an AP is going to be equal to Sn equal to n square. You can cross verify this by substituting value of n and check whether you are getting the sum of n terms. For example, if I substitute n as 7, that is sum of 7 terms of this AP, that should be equal to, wherever n is there, I'll put 7. Therefore, 7 square, that is 49. Therefore, sum of 7 terms is 49, which is already given. Similarly, if I put in place of n, I'd put as 17, that is sum of 17 terms. Again, here also n I'll replace by 17. 17 square is 289 here. Again, that is also given, that is S7 is equal to 289. Therefore, this formula is valid for any terms present in this AP. Therefore, generalized formula to calculate sum of n terms of this AP is going to be Sn equal to n square here. Okay. Next question is question number 23, which says the first term of an AP is 5, the last term is 45, and the sum is 400. Find the number of terms and the common difference. First, let us note down all the given data. Here, first term is given to us, that is a or a1 is equal to 5, and last term is, which is denoted by letter small l, is equal to 45. As also mentioned that sum of n number of terms, that is sum up to last term of this AP, is going to be equal to 400. But with this information, we do not get to know how many terms are present in this AP. That is what we need to find here, and also the common difference. Using the formula which is available for finding sum of n number of terms when we know the first term and the last term. Using this formula and substituting all the known values, Sn is equal to 400. I'll substitute 400 in place of Sn. N I'll keep as it is because we need to find this n here, and 2 as it is. In place of A, I'll substitute 5, that is first term. In place of L, I'll substitute 45, which is last term. Now, simplifying this, I get 45 plus 5 is 50, 50 by 2 is 25, 25 n is equal to 400, or n is equal to 400 by 25, which is equal to 16, which means sum of 16 number of terms is going to be equal to 400, which is nothing but 16th term is the last term, which is nothing but 45. Therefore, I can write last term as A16, which can also be represented as A plus n minus 1 into D, where n is 16, so 16 minus 1 will be 15. Therefore, A16 can also be written as A plus 15D. Now, using this information of 16th term, we already know 16th term is last term, that is equal to 45, is equal to first term is A, that is 5 plus 15 into D. Now, simplifying this or solving this for D here, we get answer as D is equal to 8 by 3. Therefore, number of terms in this AP is equal to 16 and common difference is 8 by 3. Next question is question number 24, and it says in an AP the first term is 8, nth term is 33, and the sum of first n terms is 123. Find n, that is number of terms in this AP, and also the common difference D. First, let us note on all the given data. First term, that is A or A1 is equal to 8. Then he has given us an, that is nth term is equal to 33, and sum up to this nth term is equal to 123. Again, in this case, we do not know this 33 is located at which position, that is for what value of n we'll get 33. Therefore, we are given that sum from first term till this nth term is equal to 123. Again, using this formula, Sn equal to n by 2 into a plus an, substituting all the values, we can solve this for n first, that is number of terms we'll be getting. Therefore, n is equal to 6, which means for n is equal to 6, or this 33 is present at the sixth term, we can call it as sixth term is 33. Therefore, sum up to 6 terms of this AP is equal to 123. Therefore, n is nothing but 6 here. Now, using this information, finding the common difference, I'll consider this an as a6 because n is 6 here. Therefore, a6 equal to, I can also represent this as a plus n minus 1, that is 6 minus 1, 5d. Therefore, a6 equal to a plus 5d. Substituting all the values here, a6 is equal to 33 is equal to 8 plus 5 into d. Now, solving this for d, I get answer as d is equal to 5. Therefore, n is equal to 6 and d is equal to 5 in this case. Next question is question number 25. In an AP, the first term is 22 and the nth term is minus 11, and the sum of first n terms is 66. Find n and the d, the common difference. In again, this question number 25 is exactly same as question number 24. So we'll solve this with same method. First, we'll note down given data a is equal to 22 and nth term is given to us an is equal to minus 11, and sum up to this nth term is equal to 66. Applying formula Sn equal to n by 2 into a plus an. Here a is known, an is known, and Sn is given. Using this information, we'll find n here. 66 is equal to n by 2, I'll keep as it is. A is equal to 22, and in place of an, I'll substitute minus 11. Remember, when there is a negative term, we have to put it in bracket in order to avoid the confusion. When I simplify this, I'll take this 2 on the left hand side. This denominator will come to the numerator here. That is 132 is equal to n into this plus into minus will be minus. Therefore, 22 minus 11 is 11. Now, when I bring this 11 down is equal to 12. Therefore, there are 12 number of terms in this AP up to this nth term which is given, and sum up to this 12 terms is equal to 66. Now, using this information, we'll try to find common difference D. Therefore, 12th term is nothing but minus 11, which I can also represent as a plus 11d. Using this information, I'll substitute a12 as minus 11, and a is given to me as 22 and 11 as it is, and common difference d I'll keep as it is. Simplifying this further, minus 11, and when I take this 22 on the left hand side, minus 11 minus 22 is equal to 11 into D, or minus 33 divided by 11 is equal to D, or I can say D is equal to minus 3 here. Therefore, N is equal to 12 and D is equal to minus 3 in this case. Next question is question number 26, which says the first and the last term of an AP are 7 and 49 respectively. If sum of all its terms is 420, find the common difference. This is a very simple question. We'll note on given data. First term A is equal to 7 and the last term L is equal to 49. Again, he's telling that sum of all its terms means from first term till last term is equal to 420. I can represent it as a Sn is equal to 420. Substituting all the values in this formula, I'll get 420 is equal to n by 2 and A is equal to 7 and L is equal to 49 here. Simplifying this further, 420 into 2 is equal to 840 is equal to n into 49 plus 7 is equal to 56 here. Bringing this 57 down here, I'll get n value as 50. Therefore, sum of 15 number of terms is equal to 15 terms of this AP is equal to 420, or I can also say 15th term of this AP is the last term, that is nothing but 49. Therefore, A15 is equal to A plus 14D, which I can represent as for the last term. That is, 15th term can be represented as A plus 14D. Using this information, A15 I'll keep as it is, that is, last term is 49. A is 7, which is given to me. 14 I'll keep as it is, and D I don't know. I will need to calculate this. I'll keep this as it is. So, and simplifying this, when I take this 7 on the left hand side, 49 minus 7 is equal to 14D. That is nothing but 42 divided by 14 is equal to D. Therefore, I get D is equal to 3 here. N is 15 and D is equal to 3 in this case. Coming to the last question of this part of exercise 9.6, that is nothing but question number 27, which says the first and the last term of an APR 5 and 45 respectively. If the sum of all its terms is 400, find its common difference. This question is exactly same as the previous question, question number 26, just numbers have been changed here. So first term I'll note down as 5, last term is 45, and sum up to this last term from first term is equal to 400. Applying same formula again, Sn equal to n by t into A plus L. Substituting all the values, in place of Sn I'll substitute 400, n by 2 I will keep as it is, A is equal to 5 and L is equal to 45 here. Now, simplifying this further, 400 into 2 is equal to 800, that is equal to n as it is, 45 plus 5 is 50. Therefore, n is equal to 800 divided by 50, which will give me answer as 16. Therefore, 16th term of this AP is nothing but 45, which I can also write as A16 is equal to A plus 15 into D. Now, A16 is equal to A plus 15D. I know 16th term as 45 and A, that is first term, is 5 plus 15 as it is, and common difference D I need to find out. When I simplify this, I'll get 45 minus 5 is 40, and this 15 and I bring it down, it will be equal to D. Therefore, D is equal to 8 by 3 in this case. Hope you understood all the questions that we have taken up in this video. Thank you for watching the video. Keep watching all the videos in my channel, and I'll bring one more concept and next continued part of this exercise 9.6 in my next session. Thank you for watching the video once again.